Good morning to all of you. Before we start today's session, please feel free to do event check-in. This will give you access to additional resources and information about events that we are running on Reactor, which are around similar topics to today's session. I will share the event check-in link with the event ID in the Q&A section shortly. Thank you all once again for joining us today. My name is Rashmita and I'm the event planner for Microsoft Reactor Bengaluru, India. This session will run over the next 120 minutes, including Q&A. The session is being recorded and will be uploaded to our Reactor YouTube channel within 3 to 4 days. I will share the link to our YouTube channel in the chat section soon. Quick word on our code of conduct. We display this at all Microsoft Reactor events that we run, and it's just a reminder to be aware of others. Key thing to take out here is to be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout and we do encourage you all to participate. Also, please keep your mics muted during the session. I would now like to welcome Shivam, our speaker for today's session. Shivam is an author, cloud architect, speaker, and co-founder at TechScalable. Being passionate about ever-evolving technology, he works on Azure, GCP, machine learning, and blockchain. He's also a Microsoft certified trainer. He's architects solution on cloud as well on-premise using wide array of platforms technologies. But for now, I will hand over to Shivam to begin the session. Over to you, Shivam.
Thank you. I'll just quickly share my screen. So hey guys, how are you? Good morning. And my last session was more than a month back. I'm pretty excited for today's session as well. And I already went through the chat, all the introductions and all the requirements and all the questions as such. We'll cover those questions. Now, if you have joined me for the previous sessions, you are aware that we basically take a case study and we understand the case study, and then we solve the case study, and we along with the solution, we take all the topics, all the questions, and we learn the technology, we deploy it, and so on and so forth. So just to quickly summarize what we are doing today, let me quickly change the screen. I'll open one notepad. So the very first thing is we'll go through the requirement of the customer, right? So see, I would love to explain things in a more practical manner, like by taking one production environment, and then we'll pick that up. So you can ask your questions in the chat window. The chat window is open with me. I'm not sure, Suresh, which session that one was. So now first what we'll do, we'll understand the customer requirement. So this is one of the most important part. If you want to learn any technology, you should you can say you should also understand like what problem is it solving, what is the main thing that we are trying to solve. So we'll take one scenario. There is a company called as Wide World Importers, hypothetical company, and we'll pick up their data, we'll pick up their problem statement, and you can say, and then we'll solve it. So we'll first go through the case study. We'll spend initial 15-20 minutes into it, and this is the most important part to make you understand the problem statement. Once the problem statement is clear, then we'll understand the data as well. The second thing is understand the data. Now we will look out. We'll check the relational data which they have. We'll also check the semi-structured and unstructured data which they have. And once we have seen all of that, then we'll jump into the designing of the architecture. We'll see that how are we going to solve the problem statement of this company, and we'll design the customer architecture like that. The solution with one high level architecture. Now after that, so as part of the architecture, there are multiple technologies or Azure services which we have to talk about. So we will see that. We'll talk about Azure Synapse Analytics. That's the major focus for today. We'll talk about, we'll have storage accounts and data lakes are always there, right? In big data analytics, data lake is always, it's the one which is replacing HDFS. So data lake is always going to be there. So again, but we won't be focusing much on data lake today. We are more concerned about Synapse Analytics and machine learning with Synapse Analytics like that. We will see what is, we also have one minor thing, stream analytics, not the major focus for the day. Machine learning is one of the major focus for the day. App services is just, you can say, part of the solution architecture. We have Purview as well. Purview is going to be one of the major focus for the day. Event Hub, IoT Hub, and Power BI. So Event Hub, IoT Hub are basically ingestion layer solutions, and Power BI is a Power BI tool. So these are the services which we'll be checking in various depth. Today, mostly we are focusing on Synapse. Now, the to-do for the, I'll also, after the session today, I'll give you a to-do as well. So whatever we are doing in the session, you can also reproduce it. You can also do it afterwards. You can do it in depth. And there is a proper documented workshop from Microsoft, which takes around 6 to 7 hours to deploy. But today we have around 120 minutes with us. So we'll solve a part of the solution. So we'll design the problem statement. We'll learn the major services today. We'll go into Purview, we'll go into Synapse, we'll go into AML service, and we'll deploy a part of the solution. Now, feel free to ask your questions. Use the chat window. You can also unmute and ask as well. However, if you can use the chat window, that will be great. I'll answer your questions on the way. Now, apart from this, today's session is more friendly to the beginners, and this will help you in your, you can say, if you have to deploy this in production one day, then it will be very useful for you. We'll talk about some very important differentiating factors, which comes with experience like that. And secondly, today's session is most, you can say, is aligned for data engineers, data scientists, and ML engineers as such. So if you are, or if anyone wants to learn, then you can also, this session is for you, right? Now, so let's get started. We'll start with the case study. We'll understand the problem statement of the customer. That's something which we want to spend some time into. We want to understand why we are doing it. And once we understand that, we'll also see the data as well. We'll have a look at the data. And then the architecture, and then the services which are helping us solving that architecture, right? And then we'll deploy a part of the solution. Okay, so let me quickly go back to the slide deck, and whenever required, we'll use the whiteboard to go through it, right? So today the customer is named as Wide World Importers. Now this company basically have online presence, and they also have hundreds of retail stores are there. They sell all type of products. They are more similar to how we have Walmart, or how we have Amazon might be there, Walmart might be there, Target might be there. So any retail giant which comes to your mind, you can imagine this customer to be similar to that customer. Now, being in the retail world, they understand that data is something which is very important. Data is the oxygen for the retail world, and data is something by which you can improve the experience of your customer. You can recommend products to them. You can recommend relevant products to them. You can you can associate relevant products with each other. You can, by getting the data, the retail lifecycle data, customer data, operation data, supplier data, you can reduce the churn as such. You can make sure that your the loyalty of the customer is enhanced. We can say we can do a more targeted marketing to the customer. We don't want to just send blanket emails to the customer, or just show them any recommendation of the products. We want to understand their journey with the company, and then want to target some products to them, or target different type of advertisements to the customer. That is something which this wide world importer wants to do for their end customers, right? This is the scenario of wide world importers. Now, their problem includes having huge amount of data. They have heterogeneous data storage. They have structured data. They have semi-structured data. They have unstructured data. Their data is stored in Oracle. Some of the data is in SAP HANA. Some of the data is in Teradata. They also have data in object storage. So they want us. So this data is very fragmented as such. The data is available in multiple sources as such. So this one of the main requirement of these wide world importers is that they want us to gather the data from various locations. They want the data engineers to get the data for data scientists, and once they get the data, then transform the data on the fly. And if I just brief you about the overall thought which we have, let me find the notepad one more time. So if I just use the notepad here, so see, there are various phases which we have to deal with when we face any customer like that. So if I just put it over here, so we'll have some problem with data loading. The data will be available in various different locations as such, maybe on-premise, maybe in cloud, maybe in other clouds also, right? And in multiple third-party databases as well. So right now we are thinking from Microsoft's point of view. So let's say first party and then some third party, and how do we get data from all the locations? How do you prepare your data? Now, if some of you who in the introductions were telling me about the artificial neural networks, so if you have natural language processing problem, then we prepare the data in a different manner. If we have computer vision, then the data preparation is different. If we have classical machine learning, then we have a different data preparation. So based on various type of problems, based on the problem statement itself, we are thinking of how do we prepare this data? What type of transformations are we thinking of? How do you want to normalize your data? What type of normalization do you want to do on the data? All those thoughts comes to mind. Sorry. So then how do you serve your data? Now, if in a practical statement in a company where there is a for this retail customer, for this retail client, we basically there will be multiple teams which are there. Maybe some teams are focused on the sales part of it. Some of them are focused on the marketing part of the company of that. Some of the some are website developers and so on and so forth. So various teams will be there. Now, if you have a lot of data and which is being managed by multiple teams, then how one team come to know about the data which is managed by another team? And then another problem which happens is that when you have to get the data from another team, you should also be aware of that, is this data confidential or not? And if it is confidential, then how do you handle it? How do you mask your data? So all those practical problem happens. Machine learning is not that easy that we get the data and we just see in a testing environment, in a learning environment, it might be easy, but in a practical environment, there are so many more factors which are there around the how do you handle your data, that it becomes a very big, even before you come to the model training, you have to focus on how will you make sure that things are secure as well, right? Because you are working with the confidential data of your customer. Now, data discovery becomes a problem. So this is another thing which wide world importers want us to help them with. And one of the solution which we have for them is called as Azure Purview. Azure Purview is the tool which can help us do that. Data classification, the lineage of the data. Lineage of the data will be, for example, if you are doing a transformation on the data, then data is how many phases are there, how many steps are there. Data was available transform, maybe we did OCR on top of it, we extracted the data, we stored it in some relational database. So what was the lineage of the data, what was the phases which were there, is something which we have to deal with. Then somewhere down the line comes machine learning, and then how do you do batch analytics and how do you do real-time analytics? So this is a very high level overview of the what do we have to deal with, what do we have to deal with today, from the point of view of wide world importers. So some dashboarding is also required. Now they have tremendous amount of data. So literally in the to do which I'll give you today, there will be around 30 billion rows will be there. It will take the ETL pipeline around 45 minutes to just to load the data for you in the testing in your you can say workshop environment. So it will be very hands-on, or you can say it will be very production oriented, where you will be dealing with around 30 billion rows as such. So wide world importers have 5 years of data, around 30 billion rows are there. It's in Oracle, some of it's in SAP HANA and Teradata. And they want us to discover, integrate, query the data, analyze data from various sources. They also want us to make sure that we catalog the data, that some of the data doesn't go missing somewhere, or something which is important is by chance, but because of some reason, maybe we miss on it. That is something which we have to make sure doesn't happen. Now, this problem statement is pretty big. The whiteboard importers is actually a very modern company. They are already using uh, data. They're already using IoT, and as part of the IoT scenario, they have around 50 sensors in every store. They have 100 stores, like that, 50 sensors in every store. Now the logic is that so these sensors are capturing the real-time data of the customer, now of the end customers who are like right now walking in the retail stores, and based on the time which customers spend on a part of the uh, rack in the store, we have to identify the pattern as such. Like, so for example, if somebody is more aligned towards maybe cosmetics, somebody is more aligned towards maybe clothes, somebody is more aligned towards maybe office supply, whiteware, or something like that. So and if they are not purchasing it, then your recommendation system should be able to give some, you can say, discounts in real time. And also, if, for example, the East Coast store, they open early because the sunrise is early over there, and the West Coast opens afterwards. So if there is a particular on a special day, maybe there is a particular on maybe on a sale day, or maybe some sort of special sale is going on. So if one of the store in one part of the world opens early, then looking at the pattern of the customers, we should be able to make the marketing strategy of the other store which is yet to open. So that is something also which they want us to do. So data is also coming from IoT sensors, right? So we have streaming problem as well. So when you work with streaming data, then you have to ingest it first, because now the problem is velocity. Data is coming very fast, it is coming continuously as such. So how do you ingest it, how do you handle it? And then you do have to do maybe transformation of the data in real time, then machine learning afterwards. So they also are getting some data from Twitter as well. So they are getting tweets of the customer, so sentiment analysis with that. So how do you ingest tweets versus how do you get your data from the IoT devices? That's one thing which we have to think about today for this customer. Okay, so now I think only a few more slides are there of the customer requirement. So this is what we were talking about, that they want some dashboards from the historical data and so on and so forth, right? So let's do one thing. Let's explore the data first. Then in the starting, if you have any questions, feel free to ask your questions in the chat window. I hope the customer requirement is a little clear. Let me know in the chat window if you're clear with what this customer is looking for, or what is their problem statement, or if we get a gist of it. Like, do we get a gist of what are they talking about, or not, right? So before we go into the solution design, the architecture of it, we will have a, if there is any question, just feel free to ask. Is there any question? Please go ahead. Right, you can put the question in the chat window also, if there is any question. Okay, so in the meantime, I'll just give you a walkthrough of the data. Let's have a look at the data. And I have imported the data from various locations. I'll also explain how have I done it, what is Synapse, but I just want to show you the data first. Let's have a look at the data first, and then I will explain how you can do something which is similar to this. So this is my Synapse Analytics workspace. I have already created that because it takes time to create, and I don't want to waste your time in just creating the resources. So I already have it deployed, which is not the hard part. So just click on create resource and deploy it. So this is my workspace and I have launched it over here. So it looks like that. That's how it looks like, right? Everything is on the left-hand side over here. We have some data, develop, integrate, monitor. I'll explain further what that is. I just want to show you the data first. So, right. Okay, there are two questions in the chat window. First is, are we using 30 GB? Not 30 GB, 30 billion rows are there. 30 billion rows is not 30 GB. It will be less than that. Hope it will be explained how much cluster size is needed. I'll explain that. Uh, how do you, so for example, if you have 1 GB of file, when you load that 1 GB of file in a data frame, like in a pandas data frame, uh, then how much can it explode? So generally the answer is 10 to, you can say, uh, 10 times to 20 times, like that. Like 1 GB file can explode till 10 GB or 20 GB. So accordingly, if you have to load that much of data in RAM, your RAM size should be according to that. So 1 GB file can explode till 20 GB. Generally, it happens till 10 GB, but in some scenarios, if the file was compressed, then it explodes till 20 GB. How do we find the missing data? Search for missing data for all the combinations. It seems a bit too much to check like that. The missing data is, for example, the null. If there is any null value which we have, then how can we can take care of the null values? We can find whether, let's say, if I have few columns, then what are the null values? The problem is then if I have the null values, then what do I do? So I can impute. Impute means like I can replace that some values which are missing with some maybe mean, mode, median, or maybe if I am not sure about why it is missing, then we and if we have good amount of data, then we can also drop the rows if the number of rows are not that much. Okay, so before I go in that direction, just want to show the data first. Let me see. I thought I had it open somewhere. Okay, so anyways, let me quickly open these scripts over here. And okay, then I think I closed it. So let me show you it again. So basically, let's have a look at the data of the customer. So we have this sales table. One of the table is sales table. In this table, we have transaction ID, customer ID, the product ID, quantity, price, total amount, transaction date, profit, and store ID. In which store was this uh, data captured from, where the transaction happened? This is one of the table which we are working with. Another table which we are working with is the product table, where we have the products as such. Like for example, the product ID, in which was this product sold, and what was the price, and how much profit was made on that particular product as such, average profit. Now, we also have customer information. So there is another table over here which we are dealing with, which is customer information. So the username, gender, phone number, email, and credit card information is there. Now, by looking at this table, one thing which you should realize is that, uh, okay, maybe I'm the administrator, so I can look at the data in this manner, right? Maybe, but the confidential data should not even be visible to the administrators also. We should mask it. We should encrypt it. So that is something which comes to mind. Like, okay, some of the fields seems to be very you can say confidential as such, like credit card, email, phone number, uh, which we have to deal with. Security is also important. So few columns are there, but that's what we have to deal with. Okay, just want to show you one more table, then I'll walk you through the solution as such. What are we planning? This table is the marketing campaign which is going on. So in South America, we have electronics. The campaign name is Be Unique. Some revenue was there. That target revenue was there. It was some cities are not there. In the other campaigns are fun with colors, tailored for you. Spring into summers, enjoy the moment. Fall into winter, be unique, and so on and so forth. Different marketing campaigns are going on. Some names are there of the campaigns. We don't have any details of what is there inside the campaign. Like fun with colors might be uh, something tailored for you, will be some sort of tailored products just for your requirement, or and so on and so forth, right? So but there are different campaigns as such. So one of the thing which this customer want is, wide world importer want, is that we should not just send blanket, we should not just do, we call it like, don't fire the bullets from a machine gun, and like have some targeted, focused marketing. That makes more sense. It reduces the money which we have to invest, and also it improves the, if it works, then it improves the ROI as well. So okay, so this is the various tables which we are dealing with. The various type of this is only the structured data which we have right now. Now before I I jump in solution architecture, let me take your questions over here. Max size of data in Synapse can process. Okay. Is this structured data after the ETL or is it unstructured one? One customer, one campaign. Not really. It's not that one customer will have one campaign. That depends on how much are you, what is your machine learning finding one label for one customer, or is it like a multi-label, what you're doing for your customer? So for one customer, we have two campaigns. But from the practical, from practical point of view, if you have properly done what you are doing, then by that campaign, that customer should be in the basket. Like in market basket analysis, the customer should be, you should be able to sell your product to the customer if you are doing it correctly. So one campaign, one customer makes sense. Okay, so let's get started. Let me explain it step by step, and let me explain how things are going on. And I hope you have a gist of what we have to deal with. The next slide, which I will show you, will be very big. It will have a lot of things. It's the preferred solution for this customer. It will have a lot of details over there, will be very overwhelming as well. I will show it to you to give you what we have to think for this customer. And then we will break it into smaller pieces and we'll take it step by step, right? One piece at a time is what we are thinking of. So this slide will be very, you can say, pretty overwhelming. So just hang in with me, I'll explain it as such. So this is the preferred solution for this customer, where we have multiple things which are going on right now. So if you remember, they were talking about tweets. So we have the tweets which are coming in, and those tweets are being ingested by Azure Event Hub. And here we have the IoT, you can say the stores are there, and the stores are having the IoT devices, and the data is getting streamed from those IoT devices, and it is getting ingested by the IoT Hub. So Event Hub is one directional, so you can see one side arrow is there. However, the uh, the uh, IoT Hub is bi-directional, just FYI. So you can see the arrow is like going both directions. So basically what we are doing is we are getting the data in the Azure environment, and if you can see, there is a lambda getting created over here. See, notice this. So in whenever we have customers always come up with a they always want to do things as fast as possible. The customers they always say that, okay, Shivam, show me the report in this much of, amount of time. But the problem is that if you do something very fast, you cannot do it in depth. You cannot get the proper in-depth reporting done, or you cannot have a proper analytics done if you're very fast. So Lambda architecture is a very normal way of handling such requirements, where we break the problem into two pieces. We take it as a hot path. Hot path means that we will do it as fast as possible. Some reports will be there, some analytics will be done as fast as possible. It may not be that accurate, it may not be that in depth, but it will be as fast as possible. And then if you can see, there is a cold path which is going in the bottom like that. Cold path is when you have time with you. Time means maybe you have 15 minutes, you have 30 minutes, you have 2 hours, 3 hours, 1 hour, 1 day, 7 days, and so on and so forth. Whenever you have, you're doing some cold analytics, not that real time, in cold analytics as such. So there is a data which is streaming on the top, and we have broken the data into two pieces. We are doing some hot analytics and cold analytics. And you can also notice that in the bottom of the page, we have some unstructured data is there, semi-structured data is there, some structured data is there, which is getting ingested using one product over here called as Azure Synapse Analytics pipelines, right? I'll explain it in 2 minutes. So you can see we have pipelines over here. Azure Data Lake is coming into picture. We have something called as dedicated SQL pool over here. There is something called as serverless SQL pool, and we have Spark pools over here. So notice this, we have 1, 2, 3, 4, like this. 4 things are there as part of Synapse. And in the middle, there is a data lake which is there. Apart from that, we have Power BI, Cosmos DB is there, data share is there, AML service, and some pre-built AI cognitive services. So let's pick up, let's understand what is Synapse first. Let's start from there, right? Let's take it step by step, and let's start from Synapse. Let's see what is Synapse. And as I was saying, the session will be friendly to the beginners. So we will try to break it into something which we can understand. Okay, let me find the notepad again. Okay, please notice this. Now, so what is this Synapse Analytics? Right, and I'll answer all the questions like Synapse Analytics versus Databricks versus ADF and so on and so forth. Okay, now Azure Synapse Analytics is not one product as such. It contains four things inside it. We have pipelines. Now, pipelines, they basically are ETL or ELT pipelines, right? Like that. This is similar to what is Data Factory. Like this is similar to ADF. Azure Data Factory is another pipelining ETL ELT process which we have in Azure. If you're aware of it, that's great. If not, then don't worry about it. It doesn't matter in this session. We'll understand what is pipelines. So in Azure Synapse Analytics, there is one thing which is called as pipelines inside it, by which we do ETL and ELT processes. The second thing which we have is we have a warehouse inside it over there. This warehouse is called as dedicated SQL pool, like that. Now, dedicated SQL pool, this is the one which we know as OLAP. Now, you must have heard about OLTP. You must have heard about OLAP before. OLTP, OLAP. These words are pretty popular in our, you can say, in our field of work. So this is the OLAP part of it. This is the warehouse which is there where we store data. So what do? We store data over here. So Synapse also has a warehouse inside it called as dedicated SQL pool. You store your data over there. I'll give you more information if anyone needs more information about this OLAP or what is ETL ELT. Let me know in the chat window. I'll brief you about that. It's important for us to understand the architecture over there. So this is the warehouse. Now the third thing which we have inside Synapse is called as serverless SQL pool. Okay. Now there is, whenever you work with data, you have to explore the data. Now, if I give you some files, if I give you Excel file, maybe a CSV, TSV, Parquet file, or maybe any type of file as such, the very first thing which will come to your mind is that what is the schema of this file? What is the distribution of the data? Do we have missing values? What is the range of the values? You want to explore the data. You may want to find some data which is getting repeated a lot. There is high cardinality in this data. You want to find the unique values. You want to find the repeating values and so on and so forth. You want to explore your data. We call that EDA, exploratory data analytics. So now, if I do EDA, practically, if I have to do it, I may write one Python program, and using that Python program, I may load the file into one data frame, and then I may create some graphs with matplotlib, and then have a look at the data as such, or check it out once, or maybe I in this manner. So, but in Synapse, they have provided one mechanism which we will understand in few minutes, by which we can explore our data without creating any type of you can say server or cluster, and even if the data is there right now in ADLS, data lake, or in storage account, you can run queries directly on ADLS as such using the serverless SQL pool. So I'm pretty sure if you don't know what is EDA, this might be little off, but just to make you understand, you can run queries directly on the files itself using serverless SQL pool. I'll show you what that means. Now, the fourth thing which we have is called as serverless Spark pool. Now, just to compare, this is similar to Databricks, like that. So whenever my customer asks me if I do any consulting for any customer or I have to design a solution for them, this question always comes like, why should we use Synapse when we have Databricks in the market, or why should we use the Synapse pipeline when we have ADF in the market? The answer for that is, the way I would like you to understand is that in case you just want, let's say the customer is just saying, I want ETL or I want to have ELT pipelines, like that's the only requirement they have, then it is better that you tell them to go for ADF, like which is one single product like that. Similarly, if the customer just needs a compute cluster, they are saying we are looking for that compute cluster, which is Spark cluster. So, which is the best option in as such? Databricks is very good. We can go for Databricks in Azure. However, as soon as the customer says that, okay, I am not looking for individual product. I have all the requirement. I want one. I have to ingest my data also, just like over here. You see this data loading is the problem, data preparation, transformation, serving, governance, discovery, classification, lineage, machine learning, and so on and so forth. Everything is the problem over there. Though in this scenario, now we don't have to. If you go for this, if your customer wants all the different, you can say, analytical solutions, and you suggest go for data factory, go for data bricks, then you're suggesting multiple heterogeneous solutions. Then you have to think about how will the VNet integration work, how will data move from one solution to another solution, how will my service principal or Azure AD authentication will come into picture when I'm reading my data from here to there. Which just unnecessarily adds more layer of complexity for them. uh, and it's not even required, because we have this Synapse Analytics with us. So this is one stop shop for analytics for any company, but where they are looking for multiple things, like they have the ETL requirement, they have the OLAP, they have the EDA, and the Spark requirement. They want to do machine learning or they want to work with and different things as such. So this is the first answer, that uh, you can compare pipelines with ADF. You can compare serverless Spark pool with Databricks. It is similar. I don't want to say exactly same. They are similar because they both are Spark cluster. But Databricks doesn't have this structured warehouse. They don't have this serverless SQL pool. These are different things. So in case you are looking for multiple products, then Synapse is not exactly one thing. It's a suite of product. We have four things over there by which we work and we create the analytical architectures for the clients. Okay, now just to go in little more depth, we will start with this pipelines first. So let me just quickly open my whiteboard. I just want to explain that part. Please check this out. So what about the cost of Synapse? Now, cost of Synapse is compared to other products. Pipeline cost is exactly same as ADF cost or similar to ADF cost, and Databricks will be slightly, you can say, I we need to sort of more they are similar. That's what we say, but actually it depends on your data. Like, what are you doing? Are you reading data, or what is your requirement? How much? What's the time for which you are running your jobs? So there are many more things, but the cost is similar. There is nothing which is it's not that one is very expensive, the other one is not that expensive. So if I start with the ETL first, now there are two type of systems which we have in our businesses. The systems which run the business, we call them OLTP systems, and there are systems which do the analysis of the business. We call them OLAP systems as such, the analytical processing system. ETL is the process which moves the data from OLTP to the OLAP systems. So these are relational databases. Mostly they are relational databases. Sometimes they are semi-structured databases also. These are the warehouses like that, where we store historical data, where we store last 3 years of data. This is where you will have more hot data, more real-time data, transactional data, and so on and so forth. So ETL is the process which moves it. Now the relational databases are row oriented. The warehouses are column oriented. They store data in columnar manner. The relational databases stores data in row manner, which makes a huge difference in analytics. Okay, now the second thing is, this is ETL, pretty straightforward. You read from here, you write over there. Now the second thing is, what happens if I'm reading my data from maybe from on premises? See, now if you're reading your data from on premises, you have this maybe I have Oracle on premise, or I have this data source on premise, and I'm reading my data from here. Now, if I read my data from on-prem, you it's a practical problem. See, I extract this data from on-prem. I extract, right? So if I extract, I have to put it somewhere, right? So I store it. So imagine this is ADLS in Azure. This is ADLS data lake, and I store my data. So I load my data. So this becomes that E, this becomes that L, and then you do a transformation of the data afterwards. So T. So this is that ELT process where you have to store your data in the staging location, and then you may transform your data based on your requirement. I'm not saying it's always the staging location. It's possible you are reading some sort of it's like a silver or a gold data, but that's the ELT. Like from on premises, it's more practical to do ELT. Now both are possible in the cloud. Using Azure Synapse pipeline, we can do both of it. So when this customer will, so wide world importers want us to read the data from Oracle, Teradata, and SAP HANA, which are very popular solutions in our world. So now how do you do that? If I take you back to Synapse Analytics, and I was saying that Synapse is a combination of four things over there, right? So if you have a look at this, I'll answer your rest of the questions also, like what is the uh, other things which are there, dedicated SQL pool, we'll come to that. Let's focus on this first. So if you check this out, so in Synapse over here, if I click on the let's say if I click on the integrate over here, you will notice that I have this option called as pipelines over here. You see this? Let me create one, new pipeline. So now what is this? Okay, let me make it bigger like that. So if you notice that I have this drag and drop functionality, see, I can drag and drop and make something over here. Can you see that? Like, let me see if I can find some notebook also. Okay, great. Like this. So what you are seeing in the screen is the pipeline, is Synapse pipeline. What I can do is I can get my data from source into any sink as such. So what are these sources? What are the possibilities as such? You can get your data from Amazon. You can get your data from the customer was looking from Oracle. So Oracle is supported over here. We have Oracle. The customer was Wildword importers want us to read data from Teradata, which is supported. And they also want to read the data from SAP HANA, which is also supported over here. And apart from that, we have many more locations from which we can read the data as such. You can see Amazon S3 bucket, storage accounts, MariaDB, data lake, as such, Cassandra, and the list goes ahead. If you don't FTP locations, file systems. If you don't find the connector, you can just go for HTTP based connectors as well, and so on and so forth. So these are all the source locations from where I can extract the data in this ETL process or in that ELT process, and then I can do my transformation later on as such. So now when you do this, right, when you talk about the transformation, so we have, you see this, what I'm moving right now, these are called as activities, like we call them activities as such. Now if I click on this managed option over here and I click on the linked services, you see this linked services, these are the connection configurations. So if I read my data from some particular location, you need the connection configuration. See, if you read from Oracle, you need some username, password, you need some URL to read from, table name, and so on and so forth. So we need connection to establish first. So we using these linked services, we connect to those source location, or we connect to the destination location where we have to write, or where we have to read from, or where do we have to write the data. Now, once we have these linked services, we go back. Let's go back to the pipeline over here. Now, notice these two things. Now, most probably, so you see this notebook over here. Now, I have two options over here. First thing is I can use Databricks notebook here in this step. So is it something which we use when we have Synapse? Answer is not really, but possible. Like, so here we have, like, what are these notebooks? You have 4 programming languages. You can use Scala, you can use PySpark, you can use .NET Spark, you can use basically Spark SQL. You can write your code with notebooks. So whatever data you are extracting, right, you can transform your data using the Python notebooks as such, or code-based notebooks. In case you are looking for uh, okay, let me just show this to you. So for example, if I click on new, you will notice that see, I have this drag and drop functionality. See, source, I can do some sort of metadata operation, I can do select operation, I can do filter of my data, I can clean my data, I can impute data, I can join data, I can make new columns as such. So maybe drive new columns, and then I can write my, you can say, in the sync location. So these two methods are there. The notebooks are there where we can have a code based transformation, or we have data flows where we have a code without code transformation, no code transformation, or less code transformation. uh, so both of them can be used when you are doing the transformation in your ETL or ELT pipelines as such. Both of them are practically used. Now, the reason, the how will you differentiate between them? Uh, if you can do something with data flow, when it executes, it converts into a Spark program and it runs in a Spark cluster. So data flow is also very fast. So the and it's pretty popular these days, this data flow where we can do a code less transformation, because anyone can do it. But one of the negative point is that data flow doesn't have all the functionality. If I have a nested JSON file, it cannot handle that. It will not be able to flatten the nested JSON file, because it doesn't have that flexibility of doing anything. So if you have such a data where the code uh, less transformation is not working out, we just go for the notebooks over here. Now the notebooks, if I can show you one of the notebook, it should be in this section somewhere over here. So this is one example of the notebook. So when that pipeline will execute, it will execute this notebook as the second step of that pipeline. So don't worry about what this notebook is doing, but just to show you that we can create this, you can say, these notebooks over here. And we have these four supported languages: PySpark, Scala, .NET Spark, and Spark SQL. So you can write your Python programs as such. And now there is a Spark cluster, which where it will run against that Spark cluster. So now if I use this, so what did I do? I just connected the ETL with Spark in the same one studio which I have. What you see in the screen is called a studio. Like, this is the Synapse Studio where we are designing everything over there. So it becomes very easy. It becomes like one-stop shop for doing multi-step data preparation, transformation. Anything which you want to do, you can create one pipeline around it and let it run on some schedule. And if something goes wrong, you go to the monitoring section and you monitor it. Otherwise, it will run fine. Okay. So before we go little more in the you can say rest of the solution, let me know if you have any questions in what I just showed it to you. So I just told you that there is a concept called as pipelines over here in this part, and then we can run our Python programs with Spark pool over here in Synapse itself. So any question which comes to mind in these two things, let me know. I'll differentiate between dedicated SQL pool and serverless SQL pool after that, or any other question which comes to mind. And I'll also read the questions in the meantime. Please ask a question in the chat window. Abhijit, is it clear, ETL versus ELT? Difference between it? There is another question from Girish, that Azure Synapse is part of MLOps. No, not really. Synapse is Synapse, MLOps is MLOps. They are different things. What exactly IoT Hub and Event Hub does? Okay, we'll take that. Just hang in for a few minutes. We'll take these two. The OLAP, Chaitanya, is the OLAP and ETL clear now? OLAP is the Analytical Process System Warehouses. And I will differentiate between dedicated SQL pool and serverless SQL pool in few minutes. What about the cost? I think that question is already covered. Okay, now there is a question from Nasir that if we have Spark available for free, can't we use Spark open source platform for Spark queries? Okay, Now there is a practical problem. See, now if I okay, let me go back to the whiteboard. Okay, so see Spark. If I run Spark in Azure Cloud or in any of the cloud, the open source one, I have to create virtual machines, and then I have to install Spark over there, and then I have to create a cluster manually, and then I have to run my queries as such, which becomes a very you can say very difficult to work with, because it's so much of management. Like you, the amount of time you will invest in just making sure you are reducing the cost and so on and so forth becomes very difficult. So if I go to the cloud and I'm using infrastructure as service to run my Spark cluster, then there is something wrong as such which I am doing, which we should not be doing. So in cloud, having your Spark cluster, manually running your Spark cluster in infrastructure as service in VMs is not very good. We should not do that. Now, so we have these, you can say we cannot call them PaaS solutions, but these are more managed services, uh, like managed by the cloud. As such, we have some control, but most of the responsibilities on the cloud. So we have Databricks, we have Azure Synapse Analytics, where we can run our Spark cluster. So versus that, we should go for these managed solutions. We should go for Synapse type of solution, which is automatically handling my environment, and I can focus on the productivity. I don't have to focus on the infrastructure over there. Okay, so I think there is one question on serverless pool. I'll take that now. Uh, okay, in ELT, do we need some storage? You need to store it when you load it, right? That load location needs to be some location. You have to that staging location, or maybe the after transformation also, your final gold data or your silver data that needs to be stored somewhere. You need storage, right? Okay, so okay, let me do one thing. I'll take the rest of the question, but I think it's high time that we understand what is this dedicated SQL pool and serverless SQL pool. Let's take that first, right? These two, this and that. Otherwise, it will be very confusing for us to understand. I hope these two are clear, right? The ETL, ELT, and the Spark part is a little bit clear. Let's take these two over here. Then we'll proceed further. Okay, let me open the whiteboard and just hang in with me. Okay. So, okay, let's take the dedicated SQL pool first. Dedicated SQL pool. And I'll give you a very a simple explanation of it. So those who already work on it may not be very, it will be a revision for you. Now, dedicated SQL pool, basically it's a warehouse. It stores data. It looks like this, see? We will have storage nodes are there. There are 60 distributions inside dedicated SQL pool, 60 distributions. So 60 storage distributions like that. And then we have compute nodes. These are not Spark nodes. These are internal inside the warehouse like this, like that. So like this, we have 1 to 60 compute nodes. 1 to 60. It's a scalable thing. You can pause it when you don't need it. And then we have a control node concept. So there is a control node. Control node. Now the okay, this is the architecture of dedicated SQL pool, which is inside Synapse, right? Now, what do I do with it? Like, what's the purpose of it? This is a structured warehouse. It stores data. It stores structured data. Okay, so structured data means tables are there. Now, I have this table with me, right? Like that. This table, when it will be written inside the warehouse, it will be broken. So how is it broken? You can specify the strategies by which we can do the partitioning, or by which we can distribute the data. So if I break this table, so you have to imagine in this manner that some of the data was here, some of the data was here, some of the data was here, and so on and so forth. So in 60 distribution, my table was broken and it was distributed as such. broken is a very silly word for saying distributed. There are few things you have to understand in the data engineering as such. One is called as distribution, one is partitioning and indexing, and clustered column store indexing. So a few words are there. If you understand them, then that's all. So this is the one table which is broken into those distributions. Now, if you run one query, see, you run one query, SQL query over here. What the control node works like a map reduce function. What it does, it breaks the query into smaller pieces. That query executes against the compute node. So the query executes here, 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 and so on and so forth. In those compute nodes, data come from the storage nodes like this. So data is coming from the storage nodes. So, and then the output which is coming, the control node reduces the output or aggregates the output, and then you get one output like that. So dedicated SQL pool is a warehouse which can store huge amount of data. It does that parallel computing. Uh, you break your table, you write it over there, and then you can say uh, run queries or transformation on top of it. This is also called as OLAP, analytical processing system. We do descriptive analytics with it. For example, in let's say in last 3 years, in the wide world importers, if the boss comes and says that, okay, why did the sale was good or why was the sale not good, then you will look in the warehouse. You will see that, okay, last 3 years of data, and you will find some pattern over there that, okay, because of these KPIs, or because of these reasons, the sale didn't work out in one store or in one area in last 3 years. So historical or reporting, historical analytics or descriptive analytics, warehousing is what dedicated SQL pool does, right? Now, what is the other one? This is a this is a storage location, right? It stores data. Let me write it over there. It store data. That is very important. Okay, and let me show this in the UI first, then I'll tell you the other one. So have a look at this. So let me take you to my resource group. Okay, so check this out. You see this? This one, dedicated SQL pool. That's the warehouse. It's part of Synapse. So if I take you to my Synapse, it will be listed over there. It is listed somewhere in the bottom of the page, like this one over here. Now, okay, so if we have a look at it, let's go inside it. So now the interface by which I work with it is this only. I have to work from here only. So if I click on the data over there and let it load, this is the one which is listed over here. So you will notice that 30 billion rows which I have are in these tables right now. And let me see if I can show you one query which I should have written earlier, by which I would have created the table. So yeah, okay, that's a very good query. Okay, so have a look at this. So we are creating one small table. That's the sales table, and it is hash distributed. So by customer ID, we are doing the hashing over there. Hashing will do the distribution for us, meaning one customer data will go in one distribution like that. And then we are doing a partitioning over there. So we have, I think, 12 into, okay, 24 plus 1. 25 partitions are there. So if you can notice that 2000, so data is like 2018, January, 1st January 2018, like that. Monthly data is there. See, another partition is there, 01, 02, 2018, like that. And one of the ending partition is 01, December 2019, like that. So every customer data is partitioned into 25 partitions, and it's distributed into 60 distributions. And then on top of it, we are storing the data in columnar manner. Like, we are not storing data in row manner. It is analytical processing system. So columnar manner is where we are storing the data. And on top of it, we are doing the indexing. So this table is pretty optimized. Like, it is distributed, partitioned, plus indexed, also in columnar manner. And then we have the data inside that. So if I just spend one more minute into it, this is the meaning of it. Let me just explain this same thing in the diagram. So if I explain that in the same in this diagram, have a look at this. So 25 partitions. So it is always like number of partition plus one. So if you can see 24 values here, it's always plus one, like it is left or right, but plus one is there. So 25 partitions are there. So if I make this same table in the diagram, it will look like this. So let's so let's zoom into this one. So if I zoom over there, so it will have one customer data. So imagine this is that customer data, but it is partitioned internally. So it is having like partitions like this. I'm not saying only one customer data will be there. You will have millions of customers, right? So, but uh, you can say another customer data like this. So this is January 2018. This is Feb 2018, like that, and so on and so forth, right? This is uh, and so on and so forth, March, and so on and so forth. It goes further, and then inside over here at the page level. So there is a data page, 8 KB data page over there internally, like that. Data, if the table was looking like that, let's say A, B, 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 C, C, C. So the meaning of column store is that data will be stored in this manner. A. The column will be stored in row manner, like that. So, and similarly, you will have more data pages like this, and more uh, other pages will be there like that. So we are distributing our data, plus we are doing partitioning, and then we are doing column store also, and this is indexed as well. So there is a index which is created on top of it. So uh, on top of everything. So that's how it looks like. So the dedicated SQL pool will have different distributions over there. One thing which you should remember for your from the customer's point of view is this page which I have over here. There are three type of table distributions for data engineers. Hash distribution in a dedicated SQL pool, round robin, replicated tables are there. Three type of table distributions are there. Hash distribution is done when we have data which is larger than 2 GB. Please remember that. Replicated tables are used when you have data which is less than 2 GB in size, 1.5 GB to 2 GB, like that. Round robin is the one which we use when we don't know what we are doing, sort of when we, or it is a staging table, like you have to load the data and then you will distribute it later on. Very practical way of working, like you load your data in a staging location and then you distribute it afterwards. So you can load your data in very fast manner because it's round robin, and then you can distribute your data to make it more optimized. So three type of table distributions are there. Based on the size as such, when we know very less about the data, we use round robin table distribution as such. Now, apart from that, column store is used whenever you are doing anything analytical. So whenever, if you have more than 100 billion rows, in our current requirement, they have 30 billion rows. So the column store is what we are planning to go with. Heap tables are similarly, when we are not sure about the way the data is distributed, we go with the heap tables. And when the data is less than 100 billion rows, then we go for it. Clustered indexes are the ones where we have to do a lookup on more than 100 million rows. Uh, Clustered index is a physical index. This is a non-physical index, non-clustered, meaning it's physical means like physically data will be distributed like that, and non-clustered means it's just an index. If you have some queries on some columns which are not indexed, then you make some non-clustered indexes on top of it. So non-physical. So you can have one clustered index, you can have many non-clustered indexes in your tables as well uh, over there. So dedicated SQL pool is a warehouse which store data, and we have various methods by which we can optimize the way the data is stored over there. Let me take few of the questions. And does it need to explicitly mention to store data in columnar manner? The okay, as a very good practice, or as a not really a rule of thumb, but as a very good practice, the analytical storage solutions, Parquet files, Cassandra database, uh, warehouses, they store data in columnar manner. The reason they store data in columnar manner is because in OLAP, the requirement is that you want to read few columns and billions of rows. You're not reading one row as such. You are saying that I want to read maybe, let's say 50 100 columns, but billions of rows. So if we store columns in row manner, it is very fast to retrieve from. So in analytical systems, the columnar manner of storing data is how we do it. In OLTP systems, we store data in row manner, because there we have to retrieve few rows over there. Okay, just to differentiate, dedicated SQL pool is a warehouse, right? So if my wide world importers want me to do machine learning, I may have to read my data from this dedicated SQL pool where my sales data is getting collected over a period of time. Okay, now just to differentiate between dedicated SQL pool and serverless SQL pool, check this out, and then we'll go into the machine learning part of it. The focus of the day, we'll go there. Okay, so imagine you got your data from some source. The data is right now in data lake, ADLS. Maybe it is in storage account, object storage, like that. Now your files is here, right? That's the file. That's where you are. So you want to explore your data, right? So now what Synapse let us do, Synapse let us use the serverless SQL pool to load this data, view the data, run query on the data, analyze the data, basically do EDA on the data, but it will not store the data. It doesn't store the data. It's not in storage location. It's a way in which we run queries on the files which are there in data lake or in storage accounts as such. So how is that possible? So this is also called as built-in pool over there. Someone is asking that question in the chat window. This is the built-in pool, the one which is in build or built-in, like that. Built-in pool, right? So can I show this in the UI to you? This is the one which is shown over here. See, if I go one page back, this is the one, built-in pool, like that. So this is the serverless one. Got it? So that's by default. There is no, it's totally serverless. Okay, so how do I use it? Basically, if I take you to my data, I have the data lake listed over here. So if I go to linked services, this is my data lake. So I have a few data lakes in my subscription right now, and those data lakes are listed in my Synapse Studio right now. So this is one data lake, this one. Can I'll just quickly show this to you in case somebody is new to Azure. Like, what are we talking about? This is a data lake which I have over here, right? And most of the data which I am working with is in this particular folder over here, like that. We have like data like this. Files are there, like these Parquet files are there. So I want to explore this file. See, Parquet file is something which you cannot just open like that. It's not possible to just open like this. You need some proper editor to do it. I want to explore this data. I want to have a look at this data. But how do I do it? If I just click on it, it won't show me anything. Even if I download this file might be very big in size. So how do I explore my data? So I go to the Synapse. I find the same file. It should be somewhere in this folder, small, or maybe in this one, that one, 12th month, some particular day, this file. I right click, I say explore, like this. So you see, like what it did, it is if you see, it is saying built-in pool over here. We'll say run. Okay, it will take some time to retrieve. Okay, so we were just able to explore the Parquet file without creating any cluster within seconds, as such, by using the serverless SQL pool, which doesn't store the data I can create some external tables over here. External table means like temporary tables, like pointer tables. They don't have the data. They just point to the data. They only have the schema over there. But this is my Parquet file. I can explore it now. I can see that, okay, customer ID, product IDs, and so on and so forth. I can run queries. This is normal. I can run SQL queries over here uh, like that. So the differentiating factor between serverless SQL pool and dedicated SQL pool is the ability of the dedicated SQL pool to store the data. It's a proper warehouse. Uh, you can store as many years of data as you want. And when you have to explore your data, you use the serverless SQL pool to explore that data. And then you make your strategy. How will you handle various rows and so on and so forth. And then you maybe write a Python program and all that. Now, uh, is it clear? Or you can say less demystified than before? So that's the difference between these two. Okay, I'll take a few more questions in the meantime. And then I'll tell you the machine learning part of it. What are we doing? How do we do it? And what is, how are we ingesting the data? Okay, serverless SQL pool is a default pool for running ad hoc queries. Correct. You can't persist data. It's only for querying. Absolutely correct. Yes, you are correct, Sriram. Can Synapse handle unstructured data? Very good question. Answer is yes, because we have the notebooks with us. So now you can write any program. So yes, Synapse can handle unstructured data also. You can you can handle it with Spark Pool, and the outputs can be written in any location. Okay, so there is a question from Shankar. The OLAP used to mean dimensional data. Yes. No, we still have dimensional model, Shankar, without the star schema, without your slowly changing dimensions. That concept is still there. Without that, there is no warehouse, right? Without your snowflake schema or star schema, how will you manage your data in the warehouse? That is there, and it is still columnar. Star schema is there, but the data, the way the data is stored, is still columnar. TSQL. Okay, by default, the storage is row based in Synapse. Then yes, the data is row based. Don't we have Spark R in the notebook? Okay, Spark R is not there in Synapse. In case you want to use Spark R, you have to go with Databricks. It's only in Databricks. It's not there yet in Synapse Spark. Can you compare row-oriented and column-oriented data by showing? Can you? The technical problem is it's a data page. I don't know if I can show you. There might be some way in which you can see how the page looks. Any SQL expert can give me that query, but I'll just tell you in a explanatory manner what is the meaning of that, right? And then we'll go into the machine learning part of it. Okay, so tables are logical. Please remember that. So if this is your table, then row-oriented databases, they store data in this manner. So this is the OLTP databases will store data in you can say these are data pages. In Azure, 8 KB is the size. So like that, based on your index, it will be sorted and will be stored like that. See, ABC, 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 like this, literally like that, right? ABC, 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 like this. And there will be millions and billions of pages. But okay, now this is good for the transactional systems because They just want to read. So see what happens in transactional system. If you go to any e-commerce website, you go to the order history, you click on it, you want to see your order history, you want to see your last 6 months of order history. So the requirement is not that we have to read billions of rows. We just have to read one row which is of one customer. So one row is there, or few rows of few customers. So it's very fast to retrieve one row from OLTP system, because they store data in row manner. This is row manner in which we store data. But in the analytical systems, or when we do big data analysis, if you store your data like that, and if you let's say now I imagine I have 100 columns, I want to read 20 columns out of it, right? So if I want to read 20 columns out of 100 columns and 1 billion rows, then you will be reading data like that. Like you have to skip your data, you have to traverse through the data which is not required. It's pretty difficult. It's not an optimized way of storage. Versus that, in the big data or analytical systems, in the columnar systems, the data is stored in this manner. So in columnar manner. So here we have the same 8 KB pages, but the data will go like that. So let me write it properly. R1, let's say R1A. So this is R2A. This is R3A. So R3 is the identifier, like there is a internal relationship like that. R5A, let's say R6A. So all the A's are stored together, see, like that. Similarly, here we have R1B, R2B, R2B, R3B, R4B, and so on and so forth. So the columns are stored together in the columnar databases. So now if you want to read 20 columns and billions of rows, all you have to do is you just have to read those data pages where that data exists. So it's very fast to retrieve. So in big data analytics, this is how we store data. And in the relational databases or transactional data, that's how we store the data. That's a differentiation between them. I hope that is clear, right? Okay. Now, let's go into the machine learning part of it. What options do we have and how do we do it? There are two ways in which we can do machine learning as such with Synapse over here. So this is, let's say, if we go into the machine learning part of it, now, as I'm pretty sure you guys already are aware of that in Azure, the main machine learning service is called as Azure Machine Learning Service. And we do custom AI with it. We create custom AI solutions with Azure Machine Learning Service. We have another solution called as cognitive services, which are pre-built AI. So cognitive services, here the models are already pre-trained. Maximum you can do transfer learning, and you can train the data model for your requirement, and you can work with it, but it is totally sort of ready-made type of thing. So cognitive services are pre-built like that. It's already ready-made solutions. This is where we create the custom AI like that. Now, here I have Synapse as well. This is Synapse. Now, if you have Synapse, you have the capability of using, let's say I have this dedicated SQL pool where we have 1 petabyte of data, which is stored in this dedicated SQL pool. Now, if for example, if you want to utilize, if you have a requirement, like the wide world importers right now have a requirement that they have some invoices which are lying in the storage accounts. Invoices are in PDF format. So what they want us to do OCR on top of the PDF invoices, and the output should be stored in the warehouse. So OCR is something which is already ready-made, which is available as part of cognitive services, which we don't have to really, you can say, have to code ourselves, because it's a ready-made thing which is already there. Then why should we reinvent the wheel? So the way we can have this thing done is we can create one Azure function. So what this function does, it reads these, you can say PDF over here. It checks the, with cognitive services, it finds the, you can say it does the OCR on the data, optical character recognition. It extracts the cost, the numbers from the data, and the output can be stored inside the Synapse in the warehouse. So we call this enriching our data with cognitive services. We can also do the same thing even without using Azure functions by directly utilizing the integrations are there. So for example, if I show you the example which I have created for you, is we are finding that in which season which product should be recommended to the customer based on their pattern of previous transactions. So if we train some model like that, what we can do is you can go to the serverless Spark pool. You can train your machine learning model here, and then once your model has been trained, you can register that particular. So for example, we have this XGBoost classifier, which is training the ensemble model right now, and whatever output comes, that the trained model can be stored in the Azure Machine Learning Studio as part of the model registry over here, because model registry is the one where we have. So if you, in case you want to create an MLOps pipeline, the solution which we have in Azure is, you should be using Azure Machine Learning Studio with Azure DevOps services to create the MLOps pipeline. Now Azure Synapse doesn't have that MLOps functionality. So what we do, we generally integrate Azure Synapse Serverless Spark Pool with Azure Machine Learning Studio. So for example, over here, we are using the same ML Studio, the 511 ML Studio, which is, I think this is the one, or maybe I'm showing something else. Let me, yeah, this is the one. So over here, okay, let me go back. So we are submitting the job from Synapse into the AML Studio for the model to train. The the architecture looks something like this over here, where Azure Synapse Analytics is being used for preparation of the data. We can prepare the data using Spark notebooks. We can prepare the data using SQL as well. When we are doing the training of the model, we can use Azure Machine Learning services. It supports AutoML, it supports auto hyperparameter tuning as well. It supports the MLOps pipeline creation. It supports the deployment of the models. You can create Kubernetes-based deployments. You can have container instances-based deployment. In case we want to use Databricks, it is also possible that from Synapse, Databricks can be used to train the machine learning model. It is also possible that you connect Databricks with machine learning, Azure Machine Learning Service, and then you do your training. So in a nutshell, uh, for the machine learning part of it, to create that MLOps pipeline, we are connecting the Azure Synapse Analytics with Azure Machine Learning Service, and we can train the model. We can in Azure Machine Learning Service, we can store the you can say the inferencing which is being done in the dedicated SQL pools or in other locations, and we can also have the model registered as part of AML service. So just to show you what I mean is, I'll just go back to my notebook here. So what I have done, I have already done this integration, and I have this notebook with me over here, which we have trained. So this is the same notebook where we have done the integration of uh, Synapse with AML Studio. And we are training one XGBoost classifier, which is finding that in which season, which product should be recommended to which customer. So, the way we do it is, the preparation of the data is done in Synapse. So if I just take you back over there, we prepare the data over here using the pipelines. Once let me see which one is it. I have created multiple pipelines over here. Okay, so I'll just take you back to that. So we prepare the particular data set and in the Synapse, and then what we do, we come to Azure Machine Learning Service, we go to the data store, we register the dedicated SQL pool as a data store. So this is my dedicated SQL pool. It is registered over here as a data store. Data store is just like a location where data exists, which is the which is that Synapse right now. And then we have created a data set on top of it. So data set is basically uh, we have two type of data set. We have tabular data set, we have file data set. So this is the one which we have created, the aggregated product data, which has been prepared in the Synapse and which I'm just using over here. So I think we should be able to explore it, or we may have to generate the profile if there is too many rows. Okay, great. So this is some data which we have done which we have prepared in Synapse, and then we have registered in Machine Learning Studio. So the data engineer's job was there in Synapse, and now the data scientist role starts. So basically, the data scientists go to the notebook and you can say get the data by the name. So by whatever name you have. So we have this. We are using the Azure AML SDK. So we load that into a data frame. We are setting the index to product ID, which season is it, what transaction IDs, and so on and so forth. We are doing we are treating the null values. We are doing a normalization on the data just to make sure that all the scales are there. We are reducing the dimensionality of the data by using PCA. So principal component analysis will reduce the number of columns which we have without losing any data as such in a manner. And then we are simply training one XGBoost model over here. And the reason we are using XGBoost is because, okay, now there is a question in the chat saying, why are we using XGBoost? Can't we use anything else? So XGBoost is a very popular, very good library where we have very, you can say, powerful ensemble models can be created over here. Now, the accuracy of XGBoost is very, very good as such. Now, it is not that right now, it was not that there was a linear or a non-linear relationship between the data. It was just that we were using classical machine learning. We could have used any other algorithm as well. And this is somewhere we have to do algorithm selection. Me just using XGBoost over here doesn't mean this is the best algorithm for this purpose. Maybe the algorithms which you use may end up outperforming mine. So based on your algorithm selection, whichever is the best one, you go for that. XGBoost is a very good classical machine learning algorithm. And if the problem statement becomes so complicated that classical machine learning cannot handle it, then we can go for neural networks also. Okay, so basically what we do, we train the model. It gives us one accuracy. We are actually not really checking whether it's doing it's overfitting or underfitting right now. We are just doing we are just checking it out. How much is it? How does it work? So not really, you can say right now production oriented, but we get the 82% accuracy, which is not very high. It's depends on the scenario. But what we can do is we can register the models. So once we have this model over here, we can register it. And then once the model is registered, we can deploy that. So the deployment is something which I think I have written over here. Let me quickly show you. I didn't deploy it, but you have, yeah, okay. So now, so even if I register the model, it registers, like for example, we have this model.register. It register this model in the in the AML service. You can write one scoring script. It basically has these two functions over there, init and run function. This will be inside the Docker container, which will run in the target location. So then we are deploying this solution as a Azure container instance. We can also deploy this as part of Azure Kubernetes services. Both are possible. So the environment has to be defined in the environment file. So right now we have this conda environment file, which is a YAML file in the same repository. And that's the one which will be finally, which we are registering as well for further use as well, and then we can deploy this in production. So this was that real-time deployment. Like for example, if I deploy this as ACI in ACI or in AKS, then the meaning is that we are doing some real-time scoring with this machine learning model. So let me explain that part in a again. Let me open my diagram and I'll show you that. Okay, so please check this out. Okay, so have a look at this. So the previously we were discussing the cold path, and this is where I think I should just modify this diagram, that we have the AML service and we are deploying the trained model in ACI. So this stream analytics will do a scoring with that, like this. So scoring. Now that can be stored, that can be given back to the system, and so on and so forth. But just to summarize, uh, the reason there was a question in the chat saying that why do we have single arrows on the top and why in the previous diagram there was a double arrow over here. The reason was that Event Hub is one directional. So Event Hub looks like this at the backend. So Event Hub is a PaaS solution which is built on top of Apache Kafka. So I have Apache Kafka over here. And this is Event Hub. Like, so when there are publishers of data, the data is getting published. So these are brokers, which are actually virtual machines. So the data is written in round robin manner like that, like this. And then, so this is Event Hub. Event Hub is a PaaS solution which is built on top of Apache Kafka, and Stream Analytics is just a compute solution which is reading the data. And if required, it can do machine learning inferences also. So it will do a API call right now. So you can say the model was deployed in ACI and the data came from Synapse. So something like this happened. And then ACI and then Stream Analytics was doing analysis on top of it. And it can store data wherever it want. So let me take few of more questions. Let me know is the you can say the Event Hub part of it, or the hot path. Any question which comes to mind in the hot path, or any question which comes to mind in cold path, then let me know about that. Do we? There is one question saying, are we able to use ML library which aren't natively supported in Azure ML? Yes, you can use any library which you can call. You can use TensorFlow. You can have PyTorch. You can have scikit-learn, or any library which comes to mind can be used in Azure. Okay, so let me take another question. Can you explain the columnar part of the data one more time? Okay, I'll just take that question in few minutes. Okay, so in Synapse, there is something which we have to discuss, which is very useful as well. And I'll explain I'll explain it again one more time. Check this out. See, since a very long time, if you check this architecture which we discussed in the starting, if I just take you back, we were discussing that we have OLTP systems, correct? And then we are doing ETL with it, and it goes into OLAP like that. Now, if you run your business and you have to analyze your business, the delay will be how frequently you can run the ETL job. So there is a type of system called as HTAP systems. If you combine both of them, it becomes HTAP, HTAP like this. hybrid transactional analytical processing systems. So these systems are a combination of both OLTP plus OLAP. Now, this is something which is which was there in the world since a very long time, but we didn't had anything which supports HTAP natively from Azure, which now we have, called as HTAP in Azure, which is created with the help of Cosmos DB and Azure Synapse. So this is one of the last topic which I'll just take for the wide world importers, and I'll take then your questions after that. And I'll take the row and the column question again. So what happens over here? Now we have a database in Azure called as Cosmos database. Cosmos database is a semi-structured distributed database. The way it works is so for example, if this is Cosmos DB, notice this. So inside Cosmos database, we have two parts over there. There is a OLTP part and there is a OLAP part. So and this is your let's say website which is interacting with the Cosmos DB right now. So it interacts with that, and the OLTP part stores data in row manner. So this is how the data is stored over there in row manner. And then there is an auto sync from the OLTP to OLAP, and the data is converted into columnar manner like that. So now this integrates with Synapse. We have a high speed connectivity, which is called a Synapse link as such, which connects this with Synapse over here. So in case you're looking to eliminate the ELT in your company, you can go for this HTAP environment with Cosmos DB, and this is Synapse. So this is where we have the Spark clusters. So I'll just make two clusters over here, let's say. So this is the Spark cluster like this. And in case we want to do any, okay, so the read write happens from OLTP and the read happens from OLAP. That's the way it happens. So if you want to do any hot analytics, like real-time fraud analytics or real-time, you can say IoT sensor analytics, then you can read your data from the OLTP part. You can run your, here you can have a job run, let's say, and whatever output is coming, you can maybe recommend some products or block some frauds and so on and so forth. So this is the output like this. And similarly, for batch analytics, when you let's say this job is running in real time. So this is, let's say, real time. And then here we have, let's say, 7 days of data. So you are running a job once in a 7 days. So then any batch analytics which you are doing, you can also read from the OLAP part. So this is batch mode, let's say once in 7 days type of job. And like this. And whatever output is coming, we can store it in some location. So like that. So Synapse along with Cosmos creates the newer hybrid transactional and analytical processing system called as HTAP. Now, so what it does, it eliminates that ETL because it takes around less than 2 minutes for the data to sync from OLTP to OLAP. So this is something which is very modern, where if possible, we are eliminating the ETL so we can run the business at the same time we can analyze the business. So this is what we have over here called as hybrid transactional and analytical processing system. So even if you are getting the data in real time, or even if you have batch data, you can store your data in row manner, and then it converts into it with using an auto sync into columnar manner, and we can run the analysis with Spark, and there is a connectivity between the Cosmos and the Synapse called as Spark Synapse link behind the scenes. Think it through. Any question which comes to mind Let me know about that. So there is just one more thing I want to take. Then I'll just take your questions. The wide world importers, they were also telling us that how are they going to do the discovery of the data. In Azure, we have a new service called as Azure Purview, which looks something like this. Have a look at this. Now, what happens in Purview is, even if I have, so let me just show this to you. So let's say I go to the, let's say collections, and I want to make a new collection over here. And I'll just say that, okay, this is my demo collection, like this, and create. Okay, so demo collection got created. Let's go inside demo collection. Okay, we'll click on source first. And yeah, okay, that's fine. So let's see if we can, oh, sorry, let me see if we can register some source. Okay, now have a look at this. So even in your company, if you have multiple data sources, like you have some data in AWS, some in Azure, in Synapse, maybe in S3 bucket, or you have some data in the Azure file, Cassandra, uh, you have some data in the MySQL, Oracle, Postgres SQL, and so on and so forth. What you can do is you can simply select like that. Let's say Azure multiple locations, continue, give it a name, select your subscription, give it the way you will connect. So I want this to be underneath the demo collections, and let's say register. Oh, it already exists. Okay, so generally I have already registered it over here. So, okay, let me do one thing. I'll reduce the, I won't select this. I'll just say that, and let's check it out. So subscription, workspace, let's say dedicated SQL pool, and I want this to be as part of demo collection. Let's see if it let us do it. Okay, amazing. And then we'll click on the scan over here. And now if you notice, it is asking me to select some credentials. And once I have done that, I will just scan it. Let's say continue. Okay, so what it is doing, okay, let's just say continue for now. I'll show you what it is doing, and we'll run the scan once right now, and done. Save and run. Okay, so I have done this before. Now what I did, I selected my Azure subscription. So if you have multiple teams managing the data in multiple storage locations in Azure, and you and uh, and you want that system which can catalog the data, which can tell you whether the data is confidential or not, which can tell you which team is managing what data in which data store. So the service which can scan your entire environment, which can catalog the data, the type of data for you, is called as Purview. So for example, I have selected this option before, where I selected all the Azure locations which I have, and I ran the scan. So it found around it has discovered around 96 classified data, which is as part of my data set, which I can show you from here. I can say, okay, browse my assets. So I have this wide world importers data set. Now it doesn't matter which team is managing it or what type of data storage is there. Everything is cataloged under one service. And if I just click on it, I will be able to find that how many tables are there. So for example, we only have one dedicated SQL pool, but we can see that how many tables are there. If we click on them, we can see we can give more description as such, like we can specify the properties. Some of the default information will be there by default, but you can specify more details. So what is the schema of the data? Is any column classified or not? So for example, if you remember, we had in the sales table, we had some data which was classified. Oh, sorry, not in the, let's say in the customer information over here. Let's go here. So you see this, it is telling me by default, I haven't configured that. It happened by default that email is it's saying classification email address, and phone number is US phone numbers as such. So now just by doing the scan of my environment, I can find the classifications, and I can also take an action on top of it. I can go and do the data masking as well. So the to-do lab which I'm going to give you now will have that inbuilt inside that. Like you will go and you will, once you have done the scanning, you will go and you will do the dynamic data masking. You will do some row level encryption, column level encryption before you can do machine learning over there. So in a secure manner, you can do that. Apart from this, we can also put some, we can actually edit this, and we can add which team is managing this particular table over here. So it's pretty useful for the data governance as such. Like, if you need this data, then to whom do you have to reach out to get the data? Which business process is using it? And what is the lineage of the data? So the lineage is, I think, not yet. Okay, let me just go back. Okay, so the lineage is yet not, I think, may not show anything. But what it shows is basically, if I have some data factory pipeline or some ETL pipeline, then it will show me in a very nice graph-like manner that uh, step 1, step 2, step 3, step 4. Let me see if I can, I'll show you one picture of it. I have taken one picture before, and I'll just quickly show that. Okay, so please check this out. Okay. I'm just searching in my desktop right now. Wait, let me go to the GitHub repository and show it to you over here. So check this out. So for example, that there was a result.csv file. This is a different example, but result.csv, baseball player, Twitter data, sales data, using copy data, that data was copied, and then one file was created. That one file was used by this model, and then two reports were created on top of it in Power BI dashboard. And the name of the file is customer 360 as such. So this is one example of the lineage which we have here, and this shows the entire life cycle of this data. And this is a very nice dashboard which looks that if that somebody has invested a lot of time in creating this. So if you see in the North American data center, Azure on-prem SQL Server finance data is there, Teradata finance is available, Hive metadata store is there, finance SQL Teradata on-premise. In Europe data center, SAP solutions are there. In the North America, we have the other solutions. In North America, Amazon data is also there. So Purview can scan your environment, can create a data catalog on top of it. We can create. There is a search functionality over there. You can simply go and start searching. In case you are looking for some particular values, you can search over here. So if I say I want, so I don't, I just have to search over there like anything. For example, I am looking for uh, customer names, right? Like that. So it will tell me the most probable. Okay. So in my data, I have city names, country names, customer information database is there where customer word comes, engineered feature names are there, and so on and so forth. So for example, okay, maybe engineered feature names or feature names over here. So I'll come to know that, okay, this particular information is available in which data store and who's managing it. How can I get access of it? To whom do I have to reach out to? And is some column confidential? And if it is confidential, then how do I handle it? So all the documentation can be done with the help of Purview. So this is something which we are recommending to void world importers for their heterogeneous data storage locations and their requirements. And accordingly, they can handle that. Okay, so this is what I had for the session. I'll just quickly take your questions and go through the questions as such. And if there is any previous question which was not answered, please just repaste that question. I'll take it right away. I'll just scroll a little bit up. Okay, what kind of feeds are done from Twitter? From Twitter, we are doing the full tweet body as such. You can get the full tweet body from it. Like the tweet body will have the entire the handle, uh, who commented on top of it, what were the comments, your handle, and then your information also, first name, last name, email address. So Twitter can provide us with all that data. There is one link which I'm putting in the chat window. So whatever we have discussed, the deployment is available on this page as such, hosted by Microsoft. So I'll just give you this link in the chat. This is your to-do for the session. And it is going in the chat window. So whatever we have discussed, the entire case study is hosted over there. The entire deployment is there. It will take you around 6 to 7 hours to complete it entirely. But if you just go to this hands-on part, we have it's divided into before hands-on and after hands-on. Before and during the session. So this is the some infrastructure deployment. You need Azure subscription. And once you have done this, you can go with the rest of deployment. So there are few pages over here. So whatever we have discussed, it goes into more depth, more in a structured manner. So we use the serverless pool, we populate the data, sales data, we explore the Parquet files, we explore the data using serverless pool, we do the pre-built AI, you can say integration with the Synapse. We take care of the security, column, row, dynamic data masking, machine learning part of it, monitoring as well. You can do the entire monitoring of your environment, create dashboards. So the file is hosted on GitHub. The link is in the chat window. Please bookmark it and try it out. Let us know on the Reactor group when you try this out. For this type of data set problem, how many times we will run scoring code? If you are doing batch analytics, then Nasir, you will be running the scoring code in as per the batch schedule. If you are doing real-time analytics, then the scoring will happen in real times over API calls. So it is running 24/7, or whenever the API call happens, then we do the scoring. Shankar has a question that if OLTP and OLAP systems are in sync, then OLAP structure won't be a dimensional model suitable for analysis. Okay, let me read that question again. Okay, Shankar, check this out. Your, I think, is a question related to Cosmos DB, OLTP versus OLAP? Or is it a generic question? Just let me know that. Okay. Okay. So see, check this out. So let's say this is my star schema over here. We have some star schema maybe, right? Now, this is a dimensional model which we have in the OLAP part, and this is the OLTP system. See, now OLTP system stores the data in OLAP might be aggregated as such. So just direct sync will not practically work. What we generally do, whatever data you are getting over here, you will do some transformation on it first, and then you will store it over there. Then only it will make sense in the OLAP part, like this. So that transformation is required. What are the alternatives to HTAP? How Azure HTAP is better? Okay. Now the alternatives to HTAP will be, okay, so we never had any product which was giving HTAP before. The way we were doing it is we were using multiple things together. Like you can use Cassandra database, Cassandra plus HD Insight, or any other big data service of Azure. So by using multiple databases, maybe you have some real-time SQL database, right? Or maybe some Oracle database and so on and so forth. So earlier we didn't have that HTAP, that hybrid was not there, but that same thing was being done by multiple different services together. So multiple services were being integrated to provide what HTAP now provides by default. So there was nothing which was earlier available as one solution, which was HTAP. But now today for the first time we have it where Cosmos DB and Synapse together creates the HTAP solution. So there was nothing earlier available to compare it with. What is the size of the data set for 30 billion rows? I can check it out for you. It is, let me go to my desktop, somewhere over there. It's not very big. 30 billion rows are, mm, oh, sorry, it's not in my desktop. It will take you 45. Okay, so the data is hosted by Microsoft in their location. I didn't notice what was that, but it will take you 45 minutes to load it. So when you will do the to do, so from the MS source, you will load the data into your data lake. So ADLS, this is one of the step. It will take you 45 minutes like that to load that 30 billion. You can check out how many. I didn't notice how much was the data size, but it took around 45 minutes for me to load it. There is another question that a lot of comparisons are happening between lake houses and data warehouses. Being Synapse is backed up by data warehouse, can we expect laid-out system support in Synapse in future? Yes, definitely, it will support lakehouse in future. Uh, I read some articles about it already, like making lakehouses with Synapse. Let me see if I can find that again. So the articles are, if you just Google for it, there are a few articles which are available. Let me see if I can find something from Microsoft which I can share on the chat. Otherwise, just look up for in the search browser. There are multiple articles where we are creating lake houses with Synapse. Okay, what are the efficient ways to quickly load data? Shall we use more clusters or uh, so it's a third-party link. Just look up for in the Google. Check out the first article which is there. Okay, what are the efficient ways to quickly load the data? Shall we use more clusters or split them into batches? Any suggestion? Okay. Okay, now there are two problems which you will face. Please notice this. So see, so if this is my files over here, if I compress my file, let's say you compress your files. So imagine over here. Now, tools such as ADF and Synapse pipelines can do parallel processing for you. They can have multiple parallel jobs, like 10 jobs as such, which you can run. So if you compress your files and if you have those, maybe you can say big is better. Maybe the files are compressed, but they are big in size. But at the end of the day, it will depend on what we have in the middle over here. So if I'm reading my file from on-prem, it becomes a very big problem because this network connectivity is the problem. But if we are loading the data in the cloud, then if you compress it or if you see, having more clusters will not end up reducing the bottleneck, which is the network over there. So there will be some, you can say till some point it may help, but in the end of it, you have to compress your files and move it. Then you have to you can uncompress it and then use it. So that will add one more step in your job. Okay, there is a question from Nasser in the chat saying, do we have support for Delta live tables in Databricks right now? Not sure. Delta tables are there. Not sure if Delta live tables are in Databricks supported right now or not. Okay, so any other question, guys?
I don't think so. Any other questions, Shivam? So, Rashmita, you there? There's one question from Sunil.
Okay, the data is coming from different sources. The columns and schema will be where it will be merged and how. Okay, so the this is how we are doing it. Okay, so let's say this is my source or sources of data. Now, there are two ways in which you can merge your data. One method is by using data flow, which is part of the pipelines concept. In data flow, you can add multiple sources. So like that, let's say. So this is my do a join operation, and then it becomes like that, and we can further work with it, let's say, and take it forward. So data flow is one option. But as we were talking about, data flow is basically an UI. It may not support all the functionalities which you're looking for. Then just do it in a Spark notebook. Create some data frames and join the data frames and make another data frame. Store the output, transform data, merge data into the destination location or in the sync location. So use data flow or use the Spark notebook to do it. Okay, how much the practice lab can cost? You can go for Azure free trial. You can go for Azure free trial in case it is not there. Uh, then I think if that it will take around 6 hours to deploy. So $10-20 maximum, like that.
Okay, I think we're done with all the questions. So there is event check-in link which I've just posted. You can just go to that event link and key in the event ID which is there. You'll get some content for this session as well. That's something which you can do, and join our LinkedIn group for more updates on these kind of workshops and different kind of sessions which we are doing, the Ignite unboxing or unpacking event which is happening. So do join us there. um, thanks Shivam for amazing sessions. Thank you very much. I'm just waiting for Rashmita, you there? Maybe some issue with her laptop. There is some, it was crashing from last 2 days. Okay, thank you very much all. Any questions, do reach out to Shivam. Shivam is available on LinkedIn. It would be great if Shivam, if you just post your LinkedIn ID or LinkedIn profile link there so that people can reach out to you if they have any questions on specific things.
Sure.
Thank you. Thank you for the session, Shivam. It's an amazing session.
Thank you, Vivek. Thank you. Thanks everyone for joining in.